Yeah, hello, am I audible? Yes.
Yes, sir.
Okay. So first of all, let's start with if you have any doubt in the questions given in the classes. Have you solved them? You must be facing difficulties. You will not be able to solve every question. Okay. So I'm assuming that you guys have solved the questions and you did not face any problem. So I know that that is not true. This is the hardest portion in determinants, by the way. First of all, I have checked the syllabus. There is a lot of syllabus in determinants. Uh, they have actually adjusted the whole syllabus of determinants. So this was not some things were not in the syllabus before, but this time we got the syllabus which is actually more than the previous years in determinants, and we have reduced this. I mean, CBSE have reduced the syllabus from matrices, but have increased in determinants. So we would not be able to finish determinants. I mean today, as I have discussed in the last class. So it would take some more classes to finish determinants. Okay, just wait a minute or two. Some guys are still. Okay, we can start this. Um, okay, so guys, first of all, this is the syllabus. This is the official syllabus. You can find it on the CBC website as well. But this is the official syllabus for matrices and determinants. So we have completed the part of matrices. Just one proof has been left from this portion, this proof of the uniqueness of inverse. So we will finish this in determinants as well. Because in determinants we have extended syllabus this time. So what we have done here is determinants of a square matrix up to 3 cross 3 matrices. We know how to find out the determinant of any square matrix. We have already completed minors and cofactors, right? We have completed this in matrices only, but we will revise that portion as well, right? And today's portion will be this, finding the area of triangle. Then after that, we will go to this and this portion. So this is a, I mean, starting from adjoint and inverse. This is there are two exercises which involve these four topics, but basically they are interconnected. So we will learn how to find out the inverse of a square matrix, and we have discussed about it for not in a detail, very brief discussion we had about this in matrices. So we'll complete that portion as well, and we will understand what is the application of inverse in solving some this solution, I mean, so solving linear equations. No, properties of determinant is there also. Properties of determinant is certainly there. But earlier, what used to happen is that after properties of determinant, we didn't have much syllabus. Like we just had to understand what is minors and cofactors and then adjoint and inverse. We did not have this consistency, inconsistency, and number of solutions of system of linear equations. So during previous years, this solution of system of linear equations were not there in the syllabus. Though it was in the syllabus of competitive exams, all the competitive exams include this syllabus. But earlier this was not in the series. This time we will learn how to use inverse of a square matrix in solving a system of linear equation. We actually left this portion from matrices. There are two methods to solve a system of linear equation. One is from matrices and one is from determinants. So previous years, it used to happen that we used to solve the system using matrices, but this time they have actually made a correct change. This is much used and easier as well than the method of matrices. So they have included the method of solving using determinants, not method of matrices. This is the change. So we'll be taking actually 2 more classes for determinants. This will be completed by the next week. And now this becomes a very important chapter because there are 2 portions where we can score or where we can get a question from 4 or 5 marks or 6 marks. So one portion is properties of determinants. We have finished in the last class. Please do ask your doubts. I'm very sure that you would not be able to solve all the questions given in the last class. So please ask your doubts if you have any. And if you don't have any, then try to practice a lot of questions from properties of determinants because most probably there will be a question for this topic. And the other important topic is this, which we will try to solve in the next class. Actually, we will not be able to reach by this, but the other important topic is solving a system of linear equations. So we will also learn this topic. Now let's start with the class. So we were solving these type of questions. First of all, I'll give all of you a chance again. If you have any problem, any doubt regarding the questions given to you, or you have solved any other question and you have doubt, please feel free to ask. Okay, then try to solve a few questions with me, please, from the NCERT only. Okay, I would want everyone to solve. First of all, let's start with 14th question. 14, 15, and 16. We will solve, everyone has to solve 14 and tell me the procedure. How did you solve question 14? And then 15 and 16. You will have to solve these 3 questions first in order to start with the area of interest. See, properties of determinants. Try to solve this. Okay, rather than 14, you also have the option 12. So either you can solve 12 or you can solve 14. Austin, which one are you solving? 12th or 14th first? Okay, Ira? 12. Faisal? Isaiah, am I audible?
Yes, sir.
Which one also? The 14.
The 15th one.
Which one? Sorry. You have to
15th
take
one.
one from 12th or 14. No, 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 not 15.
Okay, okay, sir. 12.
And what about Umavati?
12th, sir.
Okay. Hari?
14.
14. Chavez? Yes, can someone tell me how are you solving? What is the first approach? First step taken to solve this one. First one, 1x. It only means that you haven't solved any question because this is a very simple question. 12th one. 14th is a tough one. 12th one is a simpler one, which is using actually the technique very commonly used to solve these kind of questions. So what we, yeah, please, Chavez. Yes, you were saying something.
Add all the rows.
Yes, add all the rows or either add all the columns. So very common approach is that you make a either a column or a row same, the whole row or the whole column same. That is a very common approach, right? And here, if you apply this either on any row or any column, so add all the three rows, change row 1 to row 1 plus row 2 plus row 3, or either change column 1 to column 1 plus column 2 plus column 3. You can follow either one. I'm following row 1. Row 1 changes to row 1 plus row 2 plus row 3. Okay. So after this, your first is 1 plus x square plus x. Then your second is x plus 1 plus x square. Then your third element is x square plus x plus 1. Now you can easily see that the first row is same. How did we know that it will happen after adding row 1, row 2, row 3? Because the elements were same in all the rows. 1 x and x square. Now the first row is same. We have changed the first row to row 1 plus row 2 plus row 3. The second rows, the second and third row, both will be exactly the same as they were. Because we haven't changed row 2 and row 3. Now, why is it helpful? You can take this common, right? You can write this 1 plus x square plus x, taking this common, and we are left with 1, x square, 1, and x square, and 1. Now, this is a pretty easy condition to deal with. We've already solved this kind of questions where one row or one column is constant. We can easily subtract columns. We can easily subtract column 2 from column 1 and column 3 also from column 1. To change this to a reducible matrix, I mean to a reducible determinant, and then we'll get our answer. So please solve it after this step. Please, someone, if you're able to solve this, tell me the operations which you have applied here. I just told you the operation, actually. Tell me how to write it. We would like to make 2 zeros now. Using these constant. Make 2 zeros. Yes.
Column 2 minus column 1.
Yeah, column 2 changes to column 2 minus column 1, and
Column
we can also apply one more.
column 3 sir.
Column 3 changes to now remember, you can't do column 3 changes to column 3 minus column 2. You will see that will also, I mean, you will think that also gives us the same result, right? If we do 7, column 3 changes to column 3 minus column 2. Okay, if I do this is wrong. Why? We have discussed this in the last class. Can someone point out the reason? Why is it wrong? Okay, so we cannot use this C2 because we are already changing C2. So we have to use C1 only. We have discussed this in the last class that whatever operation you are performing, so you have changed C2 to C2 minus C1. Now you can't use C2 to change any other one. So that is why when I change C3, I again used C1. Right? So use 1 for both of them. Now after applying this, if we apply C2 changes to C2 minus C1 and C3 changes to C3 minus C1, then we will get just a yes. So we will get 1 plus x square plus x is same. Then first column will remain same. 1 x and so 1 x square and x. Second column will become 0. 1 minus x square and x square minus x. Then third column will become 0, x minus x square, and then 1 minus x. Now it can be reduced. It can be written as 1 plus x square plus x. We are reducing the first row only. So we will write the element 1 into 2 cross 2 determinant, which is 1 minus x square. We can take x common from here, and we will be left with, okay, so start taking common as well, because we want to solve the question faster, right? So 1 minus x square can be written as 1 minus x into 1 plus x. You would be clearly able to see what you can take common. And this will be x into 1 minus x. Here also x into x minus 1. And then this is 1 minus x. So from the first row, you can take 1 minus x common. And from the second row, you can take 1 minus x again common. Right? But here it is written as x minus 1. So either write minus x here, okay? Or take x minus 1 common and take minus 1 here. So I'm taking 1 minus x common from both of them. So first row gives me 1 minus x. Second row also gives me 1 minus x. So this becomes 1 minus x whole square. And this is 1 plus x square plus x. And this becomes 1 plus x. X. Then this is minus x because we have taken 1 minus x common. And it is x minus 1. So we have to take a negative common from it. And this becomes 1. Now this is 1 minus x square plus x into this becomes 1 into 1 plus x plus x. Now my question is, first you reach till this point and tell me if you didn't understand any of this. After the point we got 1, 1, 1, we should be able to solve this. I mean, after that, we don't have any other method to solve this. We know how to solve this. Make 2 zeros, reduce the matrix, reduce the determinant, and try to take common. If you can't take anything common, then solve the 2 cross 2 determinant directly. The only thing is, how do we get to make one row or one column same? Here it was easy. We changed R1 to R1 plus R2 plus R2. This is the most difficult step, I would say, from these type of questions. First step, you have to observe the pattern. You have to practice a lot of questions to understand what you can do there. But there are only 4 or 5 types of patterns. We have discussed 3 of them already. The second part is fourth. I have given you 2 parts right now. So the 14th question is fourth part of fourth series of these type of questions. We only have these 4 or 5 kind of methods. You have to practice everyone. Otherwise, you would not be able to do it. Okay, so my next question is, we don't need to prove this. If you're clear up to this point, then tell me, how did we get? Yeah, we need to prove this. This is 1 minus x cube whole square. 1 minus x cube whole square. But we got our answer in some other form. We need to prove this, right? The right hand side is 1 minus x cube whole square. But what we got is this 1 minus x whole square, then 1 plus x square plus x into 1 plus x square plus x. So we can actually write this as 1 minus x into x square plus x plus 1 whole square, if you observe. Okay, this is also square and they are also square. So 1 minus x whole square and x square plus x plus 1 whole square. Now this is the product gives you 1 minus x cube. You have already solved these kind of questions. If you remember the formula, can you please tell me what is a cube minus b cube? Formula for a cube minus b cube. Oh, फटाफट बता सकते इसको तो please. A cube minus b cube. Learned it in class 9. Faiza, do you know this a cube? What's the formula for a cube minus b cube?
So a minus b
Yes.
a square plus ab plus B square.
Correct. And if there is a plus here, then we would make plus here and negative with AB. So if this is a plus, then this would be also plus, and this would be negative. Right? Now this is the same formula we've used here. If you take 1 minus x cube, then this is 1 cube minus x cube. You can write it as 1 minus x into 1 plus x plus x square, which is the same. Yes, please feel free to ask your doubts for this particular question. Now, if you're done with this, please start solving second. This is a bit tougher, right? Can someone observe any pattern here? I mean, is there a pattern you can observe? Try to think about what are the likewise terms, or what can we take common from a row or a column? Like in first case, in every row, the elements were same. 1x and x squared. Their positions might be different, but the elements were same. But in second question, it is not the case. But we can observe a certain pattern that all the diagonal elements are a square plus 1, b square plus 1, c square plus 1. So there are three quantities involved here, a, b, and c. Right? Now one element is formed by taking square and adding 1 to it for all of them, a square plus 1, b square plus 1, c square plus 1. And the other two elements are product of 2, a, b, a, c, b, c. So product of 2 can be formed in three forms, either AB or BC or C. We have used all three of them, AB, BC, and C. So the only pattern which I can observe is that there is A involved in the first row, right? In every element. In first element as well, A square plus 1, second element AB, and third is AC. Then there is B involved in second row, and there is C involved in third row. I can also observe this in column wise. There is in the first column, A is involved in each element, B is involved in each element in column 2, and then C is involved in column 3. This is the only pattern which I can notice. But I have to observe these patterns. I have to understand how the things are going. So in these type of questions, where you see there is actually no definite pattern, but like A is involved with all three, but still see, A is involved with all the elements in row 1, but I can't take A common because A is not with this one. So I would not be able to take A common in this case from the first row. And similarly from the second row, I can't take B common. B is involved with all the elements, but B is not involved with, B is not involved as a whole. For B square plus 1, if this would have been B square plus B, I could have taken B common easily. But this is not the case here. This is B square plus 1. Right? So there is B involved in row 2, whole row 2. But still I cannot take that B common. This is the important takeaway by understanding or by looking at this determinant. Now I would use this. I would use the same fact to actually reduce this determinant. So what I'm doing is, I'm thinking that I cannot take a common from the first row. But what if I multiply the whole column 1? See, what if I multiply the whole column 1 with a, right? I can do that. I can multiply a determinant with anything. What I have, I mean, let's say there is a, just a, give me 1 minute to explain this. So what I'm writing is, let's say this is a 2 cross 2 matrix, right? So I want to multiply first row by 2. I can do that. The only thing is I will have to divide this matrix by 2 as well, because I can take that 2 common. And if I take that 2 common outside, so 2 by 2 will be 1. So I can multiply any row or any column with anything. The only thing is that I have to divide the whole determinant by that value as well, if I want to introduce something new, right? So I want to multiply this column 1 with a. And what happens with that? If I multiply the whole column a, column 1 with a, I can take a common from the whole row. That is my motivation, or that is my thinking. Now, what will be its effect? Whether it will be useful for me or not, that remains to be seen. But the only thing I can do here is, or the only logic I can relate to, is to do this. That should be my first step. There will be a lot of questions like this in which you have to make the elements look like there's something common. So I would be solving this question. Just a square plus 1 ab plus ac. Yes, solving second. Yes. So in the second question, I'm changing C1 to A times C1, changing C2, the whole of C2, B times of C2, and changing C3 to C times of C2. So I'm multiplying column 1 by A, right? I'm multiplying column B by B, and I'm multiplying columns 3 by C. Now, to do that, I will have to divide it by 1 upon A for doing this, by 1 upon B for doing this, and by 1 upon C for doing this. So I will have to divide the whole determinant by 1 upon A, B, C, because I am actually introducing A, B, and C in column 1, column 2, and column 3. So what will it look like? A into A square plus 1, A square B, and then A square C. Then again, AB square, B into B square plus 1, B square C. Then again, AC square, BC square, C into C square plus 1. Multiplied the whole column 1 with A, multiplied the whole column 2 by B, and multiply the whole column 3 by C. Right? And now you can also check that I haven't done anything wrong. Because from the first column, I can take A common still. This A gets cancelled out. From the second column, I can take B common, and similarly from the third column, I can take C common. But what I'm doing is I have multiplied this column wise. Now I'm taking common from row wise. So I can take A common from the first row. You can check this. I can take A common from the first row. So this, we are left with A square plus 1, then B square, and then again C square. Now I'm taking B common from the second row. Taking B common from the second row. So I'm left with A square, B square plus 1, and then C square. And I'm taking C common from the third row. So we are left with A square, B square, and C square plus 1. taken C common from the third element. So effectively, what we have done is we have multiplied the columns with A, B, and C, and then taking common from the rows. What did it do? It made our elements same. Now actually you can solve this question very easily. After doing this, can you spot how to solve it? And please feel free to ask if you haven't understood any step here. Okay, so how can we solve it further? Can you see that we have already we are about to solve this.
Row 2 is equal to row.
Yes. Yeah.
Row 2 is equal to row 2 minus row 1.
Rho 2 is equals to rho 2 minus rho 1. Okay. And
Row 3 is also equal to row 3 minus row 1.
yes, we can certainly follow this. What Shavis just told us, that we can change rho 2 to rho 2 minus rho 1, and then rho 3 to rho 3 minus rho 1. And then we can again follow some more transformations to solve this further. But what I would suggest you guys to do is change column. Change your first column. Now observe, if you add all the columns, you will be left with a square plus b square plus c square plus 1. Add all the columns. In the if you add first column, second column, and third column, the first element would be a square plus 1 plus b square plus c square. Second element will also be a square plus b square plus 1 plus c square. Third element will be a square plus b square plus c square plus 1. So as soon as you do this, as soon as you apply, C1 changes to C1 plus C2 plus C2. Your whole determinant becomes reducible. And this is b square, this is c square, this is b square plus 1, this is c square, this is b square, this is c square plus 1. So you can take a square plus b square plus c square plus 1 common. Now you have one column as 1, 1, 1. This is b square, this is c square, this is b square plus 1, this is c square, this is b square, and this is c square plus 1. But what Chavez has told us, that was absolutely correct. We could have solved it by using that approach as well. It may happen that we can take some more steps in using some particular approach, or some less steps using some particular approach, but you will not be able to know this. So go with whatever you have in front of you, whatever you think is correct, because that will actually, if you're performing the operations right, and if you know the drill, that what we have to do, we have to make a reducible matrix. And for that, we have to make either a row or a column such that there are 2 zeros in that row, in that column. Right? Now, as soon as I got this first column 1, 1, 1, I can apply these two rules. First is I'm changing row 2 to row 2 minus row 1, and then I'm changing row 3 to row 3 minus row 1. That will simply make them 0. So this would be 1, b square, c square. This would be 0. This would be 1. This would be 0 again. This would be 0. This would be 0. And this would be 1. Right? Into 1 square plus a square plus b square plus c square would be there. Now it can be reduced. It can be written as 1 into 1, 0, 0, 1 into 1 square, 1 plus a square plus b square plus c square. This gives you value 1. So the final answer is There are 4-5 kind of questions which will occur or which you will get to face frequently in properties of determinant. We have almost solved all the variety, but still there might be 1 or 2 questions which will be surprising or which may use some different approach. So you need to practice. Please solve all of these questions which were given to you. You may ask me, you please feel free to ask me doubts in the next class as well for properties of determinants. But don't just skip it, because there are high chances that you will be facing a question from this in the books. So don't miss it, please. Is everybody done? If there is someone who hasn't written yet, please just raise your hand so that I get to. Okay. If everybody is done, then solve these questions now. Now coming to 15. Let A be a square matrix of order 3 cross 3. Let A be a square matrix of order 3 cross 3. Then K times A, the determinant of K times A is equal to. First of all, does someone know the answer? Okay. Then we can use a property very simply. So let's say I have this delta, right? And delta is A1, B1, A2, B2. Now this says determinant of some matrix. Now the matrix here is, let's say this is A matrix, which is A1, B1 and A2, B2. And the determinant of this A matrix is delta, right? Now what I'm doing is I'm multiplying this matrix with some constant K. So the matrix will become K times A1, K times B1, K times A2, K times B2, right? I want to find out the determinant of this matrix. I know the determinant of this. I want to find out the determinant of this in terms of delta. So what I would do is I would take the determinant of Ka, which would become Ka1, Kb1, Ka2, Kb2. So I can take K common from the first row, as well as I can take common K. I can take K common from the second row. So outside there will be K square, and the determinant will be same again. So answer would be K square delta. Now this is a small proof for this question, actually. But I wanted to show you the logic. Why? What is the proof and why are we getting the answer? So understand this. Let's say the matrix was this, which consists of 2 rows and 2 columns. The order was 2. If this was a square matrix, obviously we can only find out the determinant for a square matrix. So every time there will be a square matrix, and when we multiply that matrix with a constant, so we got this Ka1, Kb1, Ka2, Kb2. Now, when we change this matrix to a determinant, the rule changes. The rule of taking common changes. In case of matrix, we multiply each and every element with a constant. But in case of determinant, we can take common from either row or either column. So the number of rows or the number of columns, which will be same in square matrix. So the number of rows or number of columns will decide how many K will be outside. And the number of rows are basically the order of the determinant. So if a order 2, this was a determinant of order 2, right? And when we multiply its original matrix by K, then the final answer was K square delta, right? So the rule is very simple, actually. I will write the rule here. So the rule is very simple actually. The rule says if for a given square matrix A of order n, so for a given square matrix, we have a square matrix A whose order is n. And we know what is the determinant of this square matrix. So let's say the determinant of A is equals to delta, right? Then the determinant of Ka, that is, if we multiply the whole matrix A by a non-zero constant K, then what will be the determinant of this whole matrix? This would be K to the power n into determinant of A. Why? Because there are n rows involved in this matrix now, and we can take common K from each row, or rather each column. So the whole power of K will be n, the order, which would be K to the power n into delta. This is important. Right? So this will do this. I mean, this will be applied in this case as well. There is order 3, right? And then we need to calculate K times A, the determinant of K times A. So it would be K cube into determinant of A. Now there might be a question based on this. I mean, there will be some questions based on this. So try to solve them. I have given you some questions in the last assignment from this. So try to solve them. And also answer me question number 16. Which of the following is correct? What is a determinant? We have talked about determinant. What is a determinant? Yes, correct, Shavish. So determinant is a number associated to a square matrix, right? We have already talked about it. The determinant can only be defined for a square matrix, and it is basically a number given to a square matrix. So 16th is C, and this would also be C. K cube into determinant of T. Right. Now, after this, we can start with area of triangle. Please try to solve these questions, guys. Otherwise, it will be difficult to cover this topic, this particular topic later on. Okay, so area of triangle. Now here we are going to start with actually a basic property. So this formula was initially used in class 10, but from the last years, we have reduced syllabus in class 10 as well. After the COVID times, a lot has changed. So you have not been taught area of triangle in class 10, I guess. But you must have studied it in class 11th or somewhere. So we know how can we find out the area of a triangle? There are certain ways to find out area of triangles, right? Now, a half base into height is one of them, right? Then initially we understood half base into height. Then in class 9th, we were introduced to Heron's formula, if you remember. Now, Heron's formula is applied when we know the lengths of all the 3 sides of a triangle. But if you don't know the length of 3 sides of a triangle, so area of a triangle can be calculated in multiple ways, depending on what information do you have from the triangle. Now there are 6 kind of useful information, or there are 6 elements of a triangle, 3 angles and 3 sides, right? Depending on what did you get from these 6, in fact 9, there are 3 vertices as well. Okay. But depending on these 9 things, how many things you got, you have a different formula for each of them. So there are many ways to find out the area of triangle. But in your syllabus, you have been introduced to 2 formulae already. One is half base into right? And second was Heron's formula. Now the third is when you have all the vertices of the triangle. So area of a triangle ABC, whose vertices are A, x1, y1, B, x2, y2, and C, x3, y3, is given by it is a very simple formula. Now, how to form this formula? You write your points x1, y1, x2, y2, and x3, y3, and make third column as 1. You write your points x1, y1, x2, y2, x3, y3, and make third column as 1. Whatever sorry, not just this, half of this. Right? Now, whatever comes the value, you always have to take the positive value because area is always positive, right? So whatever this determinant gives you the value, that would be the area of triangle. Now, we also have the formula for this, which was in class 10th already, but you haven't been taught, I guess. So this solves, if you try to solve this will be simplified to this version. X1 into y2 minus y3 plus x2 into y3 minus y1, then plus x3 into y1 minus y2. X1 into y2 minus y3 plus x2 into y3 minus y1. So you can remember this using this simple cycle rule. You have to form a cycle. So if you start from 1, you will move to 1, 2, 3. 1, 2, 3. Then if you start to 2, 2, 3, 1. Then if you start from 3, 3, 1. Complete the cycle. 1, 2, 3, 2, 3, 1, 3, 1. But this is the formula. So using this formula, I will actually. Yeah. So using this formula, we can find out the area of any triangle if we know the vertices of that triangle. Right? Now let's apply this some examples. Find the area of triangle. And we will also understand what are the applications of this. So this is a basic question based directly on the given formula. Find the area of triangle whose vertices are 3, minus 1, 4, 5, and 6, 2. So what we will do is, we know, consider the 3 points as A, 3, minus 1, B, 4, 5, and C, 6, 2. Then area of triangle ABC is given as, you use these three coordinates, 3 vertices to solve the problem. This would be 3, minus 1, then 4 and 5, and then 6 and 2. And the third column will obviously be 1. Now if I solve this, 3, minus 1, 1, 4, 5, 1, 6, 2, 1. That's obviously half of it. So I'll get the answer. Now please solve it. Tell me the answer. Half of What does this determinant reduces to? I mean, what is the answer? Solve it by extension only. Directly. G, what's the answer? 3 minus 1, 1, 4, 5, 1, 6, 2, 1. Just directly solve this determinant. Humamuddin, did you get the answer?
Doing so.
Austin,
Yes, sir.
3 minus 1, 1, 4, 5, 1, 6, 2, 1. I solve it quickly now. It's very, these things are quite easy at where we are going right now in the chapter. Faisal, did you get the answer? Or Chavez? Yes, anyone? Yes, you have to solve this and tell me the answer. Yes, Faisal, minus 50. So the only thing I wanted to tell you, but as soon as I get the negative answer, which is minus 15 in this case, I would apply a model because the area can never be negative, right? So always take absolute value for area. So this becomes 7.5 units square or square unit. So that is how we can find out the area of triangle. But obviously, we will not be asked this easy question. So we need to understand how we can apply this area of triangle in solving these two things. So let's actually first make some notes. So first point is here. Always take absolute value or rather positive value. I'm writing on it. Always take absolute value of determinant calculating area. Because area is always positive. Okay. And second is when area is given. Okay, so we will explain the second point in a bit when we will solve the question. When area is given, take both we will come to the second point. Now, the third point is the first application of the rule. If 3 points are collinear, can someone tell me what are collinear points? What is this? What do you understand by collinear? Correct, which lies on the same line. Right? Which lies on the same line. Then the area of triangle formed by these points is 0. So 3 points are collinear. Points which lie on a same line. So if we are saying the 3 points are collinear, it means that points will be certainly like this. That if you draw a line that will pass from all 3 points, A, B, and C. So we can say A, B, and C are collinear. If this is the case. So we are saying that let's say you have to prove that these 3 points are collinear. If 3 points are collinear, they will not form a triangle. And in that case, we can show that the area formed by these area of triangle formed by these 3 points is actually 0. If the area is 0, it means there is no triangle, there is no area, right? And hence the points are collinear. So this will be the first application. Sometimes you will be asked to show that these 3 points are collinear. If they ask you to show, then you will find out the area, you will solve the determinant, and you will see that the answer of the determinant is 0. Right? This is the first application. Then the second application is sometimes you will be asked to find out the equation of a straight line, which is passing through 2 points. So let's solve a question. The question says, find the equation of a line which passes through 1, 2 and 3, 1. Now, how to solve this type of question? So what we will do is we will consider a third point. Now we want to find out the equation of line. So let's say this is the equation of a line, or this is a line where one point is A, 1, 2, and another point is B, 3, 1. We need to find the equation of this line. So what we are doing is we are considering this general point x, 1. So consider whenever you are asked to form an equation of line, you will always consider a point, consider a general point on the line. As x, 1. You will take a point which is a general point on that line. And now you will tell that consider a general point on the line as A, x, y. And these points are, let's say, B and C. Then area of triangle ABC has to be 0, because we are taking a point A which lies on this line. Now the point is already passing through B and C. You have assumed a point A on the line. It means the 3 points are collinear. So we are saying as A, B, and C collinear, as A, B, and C are collinear, area of triangle ABC must be 0. Now we know what is coordinates of A. We know the coordinates of B. We know the coordinates of C. And third column has to be taken 1, 1, 1. This should be 0. You can take this 1 by 2 to the right hand side. This will become 2 into 0. It should be 0 itself. And we can solve this. So this will be x into 2 minus 1 minus y into, this will be x minus 3. Sorry, 1 minus 3. So first will be x, take x common, then delete its row, delete its column, which will be left, we will be left with 2, 1, 1, 1, which is 2 minus 1, right? Then minus times of y, I am expanding it along the first row. Delete the column of y, delete the row of y. We are left with 1, 1, 3, 1. 1, 1, 3, 1. You can solve this. How? 1 into 1 is 1, minus 3 into 1 is 3. Now, plus the third element of first row, which is 1. We are left with, if we delete the row and column, we are left with 1, 2, 3, 1, which is 1 minus 6. It should be 0. So we are left with 2 minus 1 is 1. So 1 into x is x. This will be minus 2. So this will become plus 2y. And this will be minus 5 is equals to C. This is the required equation of line, which is passing through point B, 1, 2, and point C, 3, 1. So if we focus on this particular topic area of triangle, we may be asked to find out the area of a triangle whose 3 vertices are given to. Or we may be asked that show that these points are collinear, which is both of which are pretty easy questions. Now the third kind of questions, which has a high probability of being asked, will be this: find the equation of a line which passes through these 2 points, in which you have to consider a general point, which will be x, y, and use the concept of collinearity, that is area will be 0, to solve for equation of line. Please note this, and if you have any doubt while noting this down, please feel free to ask. Everybody done? If you haven't, just raise your hand. Okay, so this is our next question. We have to find out the value of K. And we have been already given the area of this triangle. Now I have written second point, which I haven't explained. I would like to explain that point again. So in the second part, yes. So in the second part, if area is given, then both positive and negative take both positive and negative values while solving determinant. Right? This was told to you that when area is given, in this case, this particular case, area of the triangle is already given, which is 35 square units, right? And we know the vertices are 2, -6, 5, 4, and k, comma. Now you have to take, while solving this is area, this is, so area of triangle ABC, you know, it is 35 square units. You also know how to find out this area of triangle. Half of 2, -6, then 5, 4, and then k, third column would be 1, 1, 1. But while solving this, you would take its value 35 as well as -35, because you know that area will always be 35, but the value of this determinant can obviously be -35 as well. If the value of the determinant is 35 or -35, the area remains 35, right? So if you are solving the determinant and finding out the area, then you will always take that value positive. But if area is given and you have to solve the determinant, you have to go the reverse way, then you will always consider that the value of the determinant can be positive or negative, both of them. Right? Now you will get two answers for K. Please solve it. Tell me those answers for me quickly. Guys, this is, pretty easy stuff. You just have to solve the determinant, right? Guys, sorry, I would like to change this. I'm changing this to k, 1. So this is 1. Now find out the answer. The correct approach is solve the whole determinant, right? Solve the whole determinant. Take 2 to the right hand side, and after solving, equate this determinant first with 70 and then with -70, because you are taking 2 to that side. So I'm taking 2 to that side. I'm removing this as well. If I take 2 from left hand side to right hand side, it will become 70. So solve this, find out the value, and then equate it with 70 and -70. You will get two answers. Yes. What is the answer for this determinant? Has someone solved it? Yes. It doesn't matter whether your answer is correct or not. It's okay. Try to solve these. If you're not solving it, it won't improve. Concepts won't come to you, and it will be difficult to solve further portions of determinants as well. Yes, someone? Faiza, Mamuddin, Tharif, Austin, you also, please. Everyone solve it. Only Faiz and Shavism are solving, are giving the answers. So I want every one of you to include into this. So expand it along the first row. Take first element 2 into its cofactor, which would be 3. So after this, we will break it into two parts. One part is 41 minus 10k is equals to 70. And second part is 41 minus 10k is equals to minus 70. This is the value of determinant, but this is very disappointing effort. I mean, I don't know what you guys are doing, but if you're not able to solve the determinant at this stage, this is very disappointing. You can ask me your doubts. You are not even asking me if you are not able to solve it. So this would be k in this case would be minus 29 by 10. And k in this case would be, so we can write k is equals to minus 2.9 or 11.1. There are two possible values of k. And in most of the cases, there will be two possible values of k only. So these are some questions. Three kind of questions are based on particularly area of triangle. Now you can solve the whole exercise given in the NCRT. I mean, 4.3, I guess. Let me check. Yes, 4.3. So there are 5 questions in 4.3. Solve all of them. And in the next class, we have already finished minors and cofactors. So we will be discussing minors and cofactors first. We'll be revising the whole concept. Then after this, we will be actually moving on to some properties which are based on minors and cofactors only. And after that, we will be moving on to adjoint and inverse of a matrix. So in the next class, we will also be covering adjoint and inverse of a matrix along with minors and cofactors. Right? And we will only need, I guess, 2 more classes to complete this. So by the time we come to the next class, please solve all of these questions. Solve exercise 4.3 from NCRT. I'm not giving you anything from assignment yet because I believe that you have not completed the last class work. So complete all those questions, exercise 4.2 and 4.3 with NCRT.